summarizing data. Okay, so we've looked at summarizing data graphically, displaying the data graphically. Now we're going to talk about summarizing it numerically. To do that, we first have to discuss something called a distribution. And a distribution is just a really fancy word for how the values lie. Now we're going to be talking about numerical data from here on out. No more categorical data because it doesn't fit. You don't analyze categorical data in the same way. So we're all dealing with numerical data. So let's say I'm looking at test scores. Let's say I give the same test at the end of the class every year. And the scores range, let's say the lowest score I ever get might be a 40. Ranging up to 100, a perfect score. And I'm going to keep track of how people test. So let's say that the first year I give the test, I had someone that scored like a 46 and a 64, and a 72 and an 81, a 92, a 93, a 98, 77, 85, and a 61. In the second year, or second semester, I give the same test. Say I've got a 63, another 64, 75, another 81, 73, 83, 97, 85, 71, 73, another 71. So every semester I give the test, I just keep adding those. Let's say I get a 51 the next semester, a 53, 68, 69, a 70, a 73, 75, 76, 89, 93, 81, 80, 79, 78. And I keep filling in these dots. Every time I give it, I just keep adding those results to my graph. The tendency, as I keep giving this test over and over again, there's going to be a tendency for these dots to form a shape, a curve. And after so many years of giving this test, or having enough people take the test, I can actually draw a curve like this through the top of the dots that'll describe the data. And in nature, things tend to form what you guys have probably heard before as a bell curve. The technical term for that is a normal curve. It's called a normal curve because in nature, that's the shape that data normally takes. You know, the height of people will have a bell-shaped curve. Scores on a test, if you have enough people to put on there, will make a bell-shaped curve if it's done well. Naturally, things tend to fall into this normal curve. So this bell curve, there's two things I need to know to describe it, to get a good picture of it. I need to know where the middle of it is. That's called the center. And I need to know how wide it is. That's called spread. Sometimes called dispersion. Because if I have a number line, of values, let's say this is temperatures for water coming out of a faucet. And let's say that I graph, or I put my curve, I get a curve something like that. Well, the center of this curve is somewhere around 75, right? The width of it's a little tougher to discuss, but if I compare it to others, how would I say that this curve is different from that one? Would I say that it has a different center? No, it looks like it has pretty close, if not exactly, the same center. How would I describe the difference? Has more or less spread. Less spread. It's narrower, right? The purple one is narrower. So I would say that that purple one has less spread. This one, however, the blue compared to the green, would I say it has more or less spread? Better be the same because I just copied it, right? What's the difference between the blue curve and the green curve? Now it'd be the center. They have the same spread, but the blue curve is up, between 85 and 90, and the green curve center is right around 75. So they have a different center. So we need to be able to describe both of those, the center and the spread of these curves. So we're going to start out talking about measures of center. In fact, I'm going to move down here. And I'm going to just put up a very small set of numbers here to work with. Right there is my set of numbers. There are only 8 numbers in it. One possible measure of center is something called the mean. The mean is something we've all calculated since about 3rd or 4th grade. We usually refer to it as the average. How do we find the average? We add them up and divide by how many are there. Now I'm going to define n is equal to the number of items in the list. So for this case, n equals how much? 1, 2, 3, 4, 5, 6, 7, 8. So n equals 8. So my average is calculated by adding them up. This little symbol here looks kind of like an E, means add them up. I add up the values and I divide by n. I divide by how many are there. So I'm going to do 5 plus 9 plus 12 plus 13 plus 15 plus 15 plus 18 plus 24 divided by 8. So what am I going to get there? $111 divided by 8. Otherwise known as what? 13.875 approximately. Is that right? Yes? No? Did I screw something up? Is that right? When you added them up, you got 90? Let's see. I got 14, 26, 39, 69, 77, 87. Nope, I'm still coming up with 111. One thing I'll warn you, by the way, on your calculator is you're adding these up. Once you're done adding, hit equals and then hit divided by 8. Otherwise, it's just going to divide the last number by 8 and add it to the others. Yeah? So 13.875 is my mean? Okay, good. The next form measure of center is something called a median. The median is just the middle of the data. Now, to find the median, we have to do 2 things. One, we have to put them in order. Now, my set here is already in order from smallest to largest, so I don't need to worry about doing that. Second thing, then, is to find the position. Now, with a set of data like this, it would be easy enough just to cross off the first and the last and work your way in, right? Now we get here and we find, since there's an even number of numbers here, there's actually 2 that are in the middle. How do we deal with that? Well, we would add those 2 together and divide by 2. We'd average those 2 together. If it were a larger set of data, though, it might be difficult to find the position of that center. So to find the position, what we do is this. 0.5, which is 1/2, right? Times n. This tells us how many numbers are smaller than the median. So 0.5 in this case times n, which would be 8 for this set, is 4. Since this come out to be an integer or a whole number, that's telling us the median is between that position and the next one, so between the 4th and the 5th number, which is exactly what we came up with here. It's between the 4th and the 5th number. So to calculate it, we're going to add them together and divide by 2. 13 plus 15 divided by 2 is going to give us 14 to be the median. Notice that's relatively close to our mean of 13.875. The mode is the number that appears most often, the most common number. Now in this set of data, there's only one number that appears more than once, so the mode would be 15, right? It's the only one that appears more than once. Relatively close to the others, but a little bit further away. The mode is commonly thought to be the least reliable of our measures of center. The mean and median are the most reliable. Let's do another example of each of those. Let's do another data set. So here's another data set. Talk me through finding the mean. So I'm going to add them up. 13 plus 21 plus 24 plus 26. Oops, I don't know where I got my 24. 21 plus 26 plus 27 plus 28 plus 31 plus 39. Divided by how much? 7, right? There's 7 of them. So 34, 50, 77, 105, 136, 175 divided by 7, 185. Is it 185? Okay. So it divides out to be 26.42857,143. Nope. Yep. Okay. So we'll go 26.43. We'll round it off for a mean. For our median, are they put in order? Yes, they are. They're already put in order. Step 2 is going to be to find the position. How do we find the position again? 0.5 times n, so that would be 7 in this case. We get 3.5. Now, in our previous example, we had a whole number. We said that meant it was between that number and the next one. So we got a 4, so it meant it between the 4th and the 5th number. Here we get a decimal. If it's a decimal, we always round up. So that's telling us that it's the 4th number in the list is our median. So 1, 2, 3, 4. Our median is 27. Again, relatively close to the 26. Which do you think is better, the mean or the median? Most people say that they think the mean is better. Partly because that's the first one they learned, is to find the average, the mean. And it's a little bit more satisfying. You got this formula. You're adding things up. You're dividing. You're cranking out numbers, right? But let me show you something here. What if I add the number 55 to this? Now this becomes 240 divided by 8. That becomes a 30, right? My mean is a 30. My median would be at 0.5 times 8 gives me a 4, which would be between the 4th and 5th, right? So that's between 27 and 28, which is 27.5. Which one changed more, the mean or the median? The mean changed more, because 55 is not a lot, but considerably larger than the other numbers in the list. It changed the mean way more than it changed the median. Both of them are pretty good measures of center for a standard set of data. But the median is what we call more stable. An unusual value that's really big or really small compared to the others will change the mean more than it will change the median. One example that I love to give about this. 1983. University of Virginia. Advertised that the average starting salary of a graduate in their bachelor's degree, 4-year marketing program, was just under $80,000 a year, about $78,000 per year. How many of you would take a job for $78,000 right now? Now go back to 1983. In 1983, to put things in perspective, your average high school teacher was starting out at around $16,000 or $17,000 a year. $78,000 a year seems like quite the windfall. Was that statistic a lie? No, it was the truth. But what they failed to disclose was one of the graduates in the marketing program that year was a man by the name of Ralph Sampson. Mr. Sampson was 7 foot 4 inches tall, played on the Virginia basketball team, was twice named the NCAA Basketball Player of the Year, drafted #1 overall by the Houston Rockets. Do you think he made $78,000 that year? No, anybody want to guess? It was in the millions, somewhere around $8 million, I think, is what he made. That $8 million, as we saw the 55 up above here really changed our mean. That multi-million-dollar contract really changed the mean. This was a mean here. The median was around 23,000. In fact, Mr. Sampson was the only one that made more than $32,000 that year. So you can see how misleading that can be. It was because of that one really unusual value. It's an honest statistic. Oh, I won't say honest. It's an accurate statistic, but it's very misleading. It's not a very honest picture of the whole situation. Any questions? Okay. For spread, If I want to talk about measures of spread, there's a few things I can do. And I'm going to give us a little bit smaller set of numbers here. Like that. One way to express spread is the range. The range is simply the largest minus the smallest. So again, I've put these in order, so the largest number would be 23 minus the smallest number is 9, gives us a range of 14. However, it is very, very possible to have two sets of numbers with the same range. That have different spreads. What's the range of that set of numbers? Yeah, 23 minus 9 gives us 14. The exact same range. But would you say they're the same amount of spread out? If I put them on a number line, my black numbers would look like this. My green set of numbers look like that. Which ones would you say are more spread out? The greens. Yeah, the blacks are very tight in the middle here. You can see they're kind of pushed together. The greens more evenly spread out. There's more distance between them. So how do we quantify that? The range isn't going to do it. So we'll talk about something called a standard deviation. Now there is a formula for standard deviation. It looks like that. That formula probably looks German to a lot of you. So what we're going to do is we're going to define it as a 6-step process. Step 1 in our process is to find the mean. So I'm going to start out with our first set of numbers here. So the mean, 9 plus 13 plus 14 plus 16 plus 23, divided by 5, because there's 5 numbers. What's that come out to be? 15, I believe, right? Is our mean? Yep. Okay. So that's step 1, is to find the mean. Step 2 is subtract the mean from each number. So I have my 9, my 13, 14, 16, and 23. I am going to subtract my mean from each of them. So 9 minus 15 is a negative 6. 13 minus 15 is a negative 2. 14 minus 15 is a negative 1. 16 minus 15 is a positive 1. 23 minus 15 is 8. Now to double check, this doesn't mean anything to our calculation, but if you wanted to double check, if you add those up right here, they should add up to 0. Again, we don't need to do that, but if you wanted to double check, if it's not 0, you did something wrong. Either your mean is wrong or you subtracted something wrong or something. Step 3 is to square each. So negative 6 squared. If I told you that's a negative 36, what would you tell me? What would you say if I wrote down negative 36? Any number squared has to be positive. Now, some of you out there may have punched in your calculator and come up with a negative 36. Why would it do that to you? Because you may have forgot the parentheses. It has to be in parentheses when you square negative. Negative 2 squared is 4. Remember, any number squared will always be a positive result, no matter what. Negative 1 squared is 1. Positive 1 squared is 1. And 8 squared is 64. Any questions so far? Step 4 is to find the total. Add those up. If I add those up, I get 106. Step 5 is a little tricky. Is divide by n minus 1. So for this set of data, what's n equal? 5. There were 5 numbers, right? So that means n minus 1 is going to equal 5 minus 1, or 4. So we're going to divide by 4, which is going to give us 26.5. Now, if you were asked for it, this number here, 26.5, is something called the variance. If we were to go into advanced statistics, like doing statistical tests and statistical comparisons and stuff like that, the variance is an important number. What we're concerned about now is something called the standard deviation, which requires us to go one more step. Step 6 is to find the square root. Now, do not confuse this with step 3. Step 3 was to do what? Square the number, multiply it by itself. Square root is this. It's the opposite. The square root of 26.5 is going to be 5.15. That is my standard deviation. That set of numbers. Now my other set of numbers, 9, 10, 17, 21, 23. We said look to be more spread out. Well, let's see what we get. What's step 1? Find the mean. Tell me what to do. Add them together. What do those add up to? Add up to 80? So divided by 5 is 16. What's step 2? Okay, we're going to subtract the mean from each. You got it. So 9, 10, I'll put them down here. 17, 21, and 23. We are going to subtract 16 from each of those. 9 minus 16 is negative 7. 10 minus 16, negative 6. 17 minus 16, 1. 20 minus 16, 5. And 23 minus 16, 7. Now, like I said, I don't have to do it, but what should those add up to right now? 0. Very good. What's step 3? Not square root, but square. So negative 7 squared is 49. Negative 6 squared, 36. 1 squared, 1. 5 squared, 25, and 7 squared, 49. What are those? What's step 4? Find the total. And that adds up to, what, 160? Yep. Step 5. Divide by n minus 1. So that means we're going to divide by what here? 5 minus 1, which will be 4. So we get 40. Now 40 would be the variance again. But again, we're not looking for the variance. We are looking for the standard deviation. So we have to do step 6, which is square root 40. The square root of 40 gives us 6.32. That is our standard deviation. You compare that, we had a 5.15 up there. 6.32 is more spread out. It's a bigger number. So it does work out. Standard deviation is not a happy calculation to do by hand. I would never ask you to do it with more than like 6 or 7 numbers at the most. Just because, well, I don't hate you that much. I think in the homework it may ask you to do it with like 7 or 8 total. But like on a test, I would never ask more than, I said 5, 6, maybe 7 at the most. Any questions? Okay, well. There's a new quiz due today by 11:59 p.m. And there is a new homework. It is due for Thursday. On Thursday, we will talk more about statistics, means, standard deviations, medians, what they're used for, what we can use them for. Next week, Monday, we'll talk a little bit more about some new statistics, and then it'll be review for our test on Tuesday. Tuesday's class is scheduled completely for the test. What I figured usually happens is it takes about 2 hours to get through the test. In the last 40 minutes, we'll do a little review for Thursday's final. Remember, the final test on Thursday is more to evaluate the course than it is to evaluate you. It can help you, but it cannot hurt you. The only way it'll hurt you is if you don't take it. If you don't show up on Thursday, it will hurt you. Okay.